All right, I am the king of turning the complex into the simple. Okay? And those who love me know that. My pins. Okay. All right, here we go. This is we got to use our 5-step method. Okay? Our factoring. Okay? Factoring, we should think F 5-step. Okay? All right. So, the cool part to these is that they're really not 5-steppers. They're the 3-steppers. Okay? But let's talk about that. Now, the 5-step method starts with GCF. And if you watch the other videos, I step through that. Okay? And the GCF means that I need to see what goes into 1, 4, and 5. Well, the only number that goes into 1, 4, and 5 is 1, right? So then there's no GCF. It's that simple. Okay? And so we move to the second step. And the second step is parentheses star variable. Okay? Now the star is always the first coefficient. Right? It's that number that's out in front. And what number is out in front? 1, right? So there's nothing. So if there's no star, then there's no star cleanup. Okay? And that's what I mean by a 3-step method. Is that it's really just 2, 3, and 4. Does that make sense? Okay? So then I didn't finish. So this is parentheses star variable. So what we do is we're going to go parentheses. There is no star. And so I just put the variable in there. Half of how many are there? There's 2 of them, right? What's half of 2? 1. So I'll put 1 and 1. If there were 6 of them, if it was x to the 6th, I would put x to the 3rd and x to the 3rd, right? Always half. Okay? If it's x to the 5th, I can't have half, right? So I can't do it unless I GCF out maybe a variable or 2. Okay? Does that make sense? Alright. So that's it. That's that second step. It's just parentheses and a variable. We can all do that, yeah? We can all do that. Okay? Alright, then we're going to go signs. Okay? Signs means I'm going to take this first sign and I'm going to bring it up. Not asking the world here. That's pretty simple, yeah? I'm going to take that first sign and I'm going to bring it up. Okay? Now, the second sign tells me if these signs are the same or if they are different. Okay? If this sign is a difference, then they are different. If this sign is a sum, then they are the same. Okay? Sum, same. Difference, different. I try to keep it really easy. Does that make sense? Okay? So, it is a difference, so these have to be different. If it is a difference, they are different. They have, okay? Sum is the same. Difference is different. Say it with me now.
That's literally, you are literally saying, oh my God,
what? Right? Okay.
No, you are, that is literally like going Dan's father's son. Like, I don't even get what he means by saying sum is the same.
Is a sum a plus?
If the second sign is a plus sign, they're the same.
They're going to be the same. They're going to be the same sign.
I've been doing that wrong since doing it last semester.
Then we got to fix it.
How did I make it this time?
Maybe you weren't doing it wrong. Maybe you were thinking you were. We talked about it on the last test, when we were doing that last test, and you were like, you said it a certain way to me, and I go, yeah, okay, we'll go that way. And it made sense to you saying it that different way. I can't remember what that way is right now. Huh?
They're the same.
If this is a plus, then they are the same. These are the same right now, right? But we're not talking about these two. We're talking about these two. The only thing we care about is this tells us if these two signs are the same or if they're different. So these two signs depend on this. If this is a plus, then both of those are going to be the same. If it's a minus, then both of them are going to be different. Okay? Cool. And so different from this would be a... Different from a minus would be a plus. Okay? Different from a minus would be a plus. And you'll get more used to it. Believe me. We're going to be doing this every day for the next 3 weeks. Okay? So when I go, hey, is this the same or different? You'll be like, different. Then this is different. Okay. It'll come. I promise. Okay? Alright, so that is signs. Okay, signs are, the first one goes up, the second one tells me if they're the same or different. That's it. They're either going to be the same or they're going to be different. Okay, they are different. Okay, cool. Next, step 4. I need another color. Step 4 is product and sum. Now the product is always the first number times the last number, right? But there is no first number. Okay? So that's where these become a lot easier. When you recognize that they're 3-step methods, it becomes a lot easier. Because what is 1 times 5? This is 5, right? Okay, so it's always going to be this last number. When there's no number here, it's always this number. Okay? And then the sum is that middle number. So it's always going to be that middle number. Now this is what we're doing in the sum. So we're subtracting. That's why they're different. They're different because they're going to be subtracting. Right? When you're adding two signs that are different, they subtract. Does that make sense? So when they're different, we're subtracting. When they're a sum, or they're positive, right? When this is a plus, they'll be the same. Even if they're both minus, we're adding them. If they're both pluses, we're adding them. Does that make sense? Okay? So one number's multiplied to be 5, but they subtract to be 4. 5 and 1. Okay? And so that's that first step. And so coming down here, I have x minus 5 and x plus 1. Right? Now on this next one, we don't have to go through all these steps like we just did. If you start to get the feel, you're like, hey, wait a minute. This is a 3-step method, right? And the easy way to think about that is what multiplies to be a 2, but whatever this sign is, in this case, adds to be a 3. It always does that with the 3-step method. Okay? So again, GCF, none. Oh. So this is 2x, x, and then the signs come down. So this sign comes down. And it's a sum, so they are the same. So if these are the same, then this has to be a difference. Good. A difference. It's kind of weird saying it like that. I just say minus. Right? But yeah, you're right. It's a difference. So if they're the sum, they're going to be the same, so they both have to be minus. Does that make sense? I know it's confusing a little bit. I know it is. I'm trying to make it as easy as I can. I promise you that. Okay? Alright, then we got your product and sum. And the product is 2, and the sum is 3. Right? So we need two numbers that multiply to be 2, but in this case they add to be 3. 2 and 1. Good. So we've got x minus 2 and x minus 1. Alright. Here comes the hard part. This is a division one, right? What do you do when you divide? Yeah, you do something before you multiply though. Think of this. You flip them and you multiply, right? You flip these ones, right? So you go, okay, that's 3/5 times 4/3, right? Or sorry, 4/2, right? And then you multiply it. Does that make sense? We're going to do the same thing here. We're going to flip this and then multiply it. So we're going to have x squared minus 4 over x squared minus 3x minus 10. And now we can multiply. Does that make sense? So we took care of this business, but now we had to flip this, and now we can multiply it. But to multiply, we got to break it all apart, right? All right, let's do the easy one first. Which one's easy, by the way? It is. The top one is easy if you know the rule. Who said the top one? Okay. Do you know the rule? Okay. Who knows the rule to the top one? Yeah, that's what I was thinking. So, I think the easier... Oh, you got it?
Is it because there's no middle one? There's no like product?
Yeah. There's no sum in the middle, right? There is a sum, but the sum is 0. So you're really saying what multiplies to be 4, but subtracts to be 0. What subtracts to be 0. Multiplies to be 4, but subtracts to be 0. 2 and 2. 2 times 2 is 4, but they subtract to be 0. Right? And they're different, right? So you have... And the way I usually teach this is that it's a difference of 2 squares. Right? It's called a difference of 2 squares. Because what's the square root of this? Like x times x is x squared, right? What times itself is 4. And then what they do is this is called the conjugate. And so you would write the conjugate, right? It's a long... messed up word that people don't really... So when I teach it, I go, hey, this is just like 5-step method, except x squared minus 0x minus 4. And you can actually do it now. You say, okay, x minus plus what multiplies to be 4, but it adds to be 0. 2 and 2. Does that help? A little bit? Okay. Alright. And then on this one, what are we going to do? Same thing. Boom, 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 boom. X. This sign comes down. What's this sign tell me? Different. So what's different from minus? Okay? What multiplies to be 10, but it subtracts, good, it subtracts to be 3. You're getting it. Five and 2. Good.
Oh, that wasn't me. Can't even do quick math like that.
I know it's tough. And so sometimes you have to go, okay, well, what multiplies to be 10? 10 and 1, 2 and 5, and that's about it. And then you do the subtraction part. Does that make sense? And you go, okay, well, I know it's 10 and 1, and I know it's 2 and 5, but I want them to become 3, so it has to be this one. Does that make sense? Because sometimes you're going to get like 28. Well, 28's like 1 and 28, 2 and 14, 4 and 7, right? And so if it's 3, it's going to be 4 and 7, right? If it's 11 or 12, it's going to be 2 and 14, right? And so forth. All right, let's rewrite this really quick. X minus 5, x plus 1, x minus 2, x plus 2, x minus 2, x minus 1, x plus minus 5, and x plus 2. All right. Are there any the same on the top and the bottom?
Yes.
What?
X minus 5.
X minus 5,
X plus 2.
x plus 2,
X minus 2.
x minus 2. That's it? Wasn't that fun though? That should have been the fun part. Yeah, you know, there's not a lot of fun in math, but hey, have a little fun. X plus 1 over x minus 1, and there it is. And it's a lot of steps. It's a lot of steps. I know it. I know it. This is not easy. But if you follow the pattern, I swear.